This workshop is focused at normal hardware that we're using, that's BCI focused, Open BCI ganglion, and muses, EXG pills, etc. So here we begin. It's going to be a short workshop, so I won't take any time off of your hacking. Let's get to it. Small introduction about myself. I'm the Vice President Hardware for this year's natHACKS, and I'm doing computing science in UFA specialization. My name is Ritik Kumar, and I'll be your host tonight. Okay. Questions about slides. I'm going to make every anything that I talk about over here available on that portal. The links to the slides will be available on that portal. Table of contents. Introduction, hardware recap, connecting the hardware, and some handy tips. All right, introduction. Why are we here doing this workshop today? So many of you had questions about how Muse can collect data, perhaps even OpenBCI. Now, we could solve that issue by using one of the boilerplates that NAT provides. I will be going ahead and demoing that for you after we do a short hardware recap of what all we have in our inventory. First one would be the ganglion, obviously, are stealing the show of tonight. Okay. Next one is the bioamp, the NeoArduino, Unicorn, Muse2, Muse-S, and the Arduino. The Raspberry Pi and the Arduino are microcontroller boards and SBCs, which you can use to collect or incorporate between your PC and the sensors itself. Now, let's focus at connecting the hardware. Now, let's show you the main slides. We have our, one second. Okay. Right here, if you go to the NeurAlbertaTech NeurAlbertaTech repository on GitHub, you will find a NAT boilerplate, which is over here. natHACKS 2023 Python boilerplate is specifically what you should be looking for, because we have last year's boilerplate here as well, which is not updated. This one is. Once you guys come in here, I would love if you guys clone it and start using it. I'm going to demo how to install the necessary repositories. Let's get on with it. Just give me a minute. There it is. Okay, once you have cloned the repository and have it on your PC, we can go ahead from here. Let's do a small ls just to see what all exists. All of the files are connected to each other, where your basic main file would be the main_menu.py. Just once again. Is that clear for you guys? Can I have a thumbs up? Okay. Okay. Nah, too big. Okay. All right. I'm going to keep it short. Let me just give you a small demo of the README file. Over here, you'll find the most basic installation guide, which you need to have, your Python being the most topmost, and clone the repository. For macOS, you run these commands. I suggest everyone runs it on a virtual environment and not on your PC directly. That way, you don't mess up any existing libraries or modules that you have in your PC. Another thing, to make it short, we have a requirements.txt file, which you can run directly, and it'll install any necessary files. And we go ahead from here. We just run the main_py. Okay, that's it. Okay, right here we have the GUI that's formed by the pyqt5 or /6, can be used with both. And over here, it's pretty simple. You select your hardware which you require. I would suggest not using it with the exgpl as it's not the most responsive. Next, we can select the model that you want to use. Let's start with OpenBCI. In this hackathon, we are offering only our Ganglion. So let's choose that. This is going to be the name of the file that you're going to be saving onto your PC. Okay. So you could choose to test out the hardware by using task live or task simulate to just see if your code is working, where you're extracting the data, and if it responds to it or not. Because otherwise, having the hardware on all the time will give you wrong readings. Let's do live. I'm going to try connect my Ganglion just to demo it to you guys. Yep. Turn it on. For specifically this Python boiler, you don't have to rely on their Bluetooth. You can use the BLED dongle. If you don't have one, you can ask one at the hardware station. And let's connect. Okay, here we go. It took a few tries because the code is written in such a way that it channels through all of my ports existing. Because I'm using a dongle right now, so it has multiple ports, so it has to channel through everything. Here's the graph, which the ganglion is picking up. I'm gonna try working with it. Let's go. All of this data is live. Another thing I would suggest is going to the OpenBCI documentation to have good knowledge about what channels produce what kind of waves. And everyone's been asking me questions how to extract the data through it. So this is why we came up with the Python boiler. And this works with the Muse as well. As you know, the API is not available for Muse because, well, they decided not to give it to us. Now, we will use this for Muse, extract the data. I also recommend using Petal if you have to. Petal is another open source software that you can use to extract live data from Muse. I would suggest going with this. It's more convenient. And let's stop that over here. Okay, let's go next. I had to maximize it. Come on, please bear with it. Hey, come on, work. There we are. Okay, that was a very short demo for everyone. I'm not going to take any more of your time except the small handy tips. Yay, we need handy tips. Okay, first one, documentation. If you come to me, you ask me any questions, I learned it all from the documentation itself. If I know anything, it's from the documentation. Plus, well, if you can't find on the documentation, you still have any doubts, you can find me at the hardware station or any other hardware volunteer. Now, when you go through the documentation, make sure you're choosing Ganglion as your hardware because I believe Saturn Daisy and Daisy also have the documentation for it, so don't mess up that part, as OpenBCI makes different boards. Another thing would be for Muse. Muse's documentation refers to the API quite a lot, so We don't have the APIs, so that I solve it just to remove your confusion. Next one, the jumper cables, or DuPont cables as we call it, the multicolored cables that I gave you with your hardware. Some of the cables can be damaged, so make sure if you're not getting an output from a sensor, make sure to get replacements. Now, it's not an issue at our end, it's just that some some manufacturing defects can be there. So just to avoid that, make sure if you need any, please ask me. Next, let's go to the wireless connectivity part. We give out BLED 112, which is basically a Bluetooth dongle for our BCI hardware. Open BCI Ganglion's box, the kit, comes with it for Muse 2 and Muse S. If you require one, you can ask me at the station. We will give you one. And if you want to use the native Bluetooth from your Muse to your MacBook or your Windows laptop, /Windows/Linux, etc., you should be using the BLED for more accurate data output. And another thing, once you reset your OpenBCI, imagine you disconnect the electrodes and connect them back again, make sure to restart your ganglion, because it has to reset to detect the new electrode that's been joined. Oh, it's working. Okay, the new electrode that's just joined. And same goes for the Muse. When you restart the ganglion, make sure to unplug and replug your BLED, which is your Bluetooth dongle, to make sure it doesn't have any other errors. Batteries and powers. We have a few variables that we are giving out as well. Now, those come with different types of batteries. Some can be 400 amps, 200 amps, 150, whatnot. We have all kinds of batteries. Go through the documentation, read what it requires, which battery goes with what kind of hardware. Do not put a battery to a piece of hardware without checking what kind of voltage or milliamp hours it needs. You could simply just ruin the hardware itself just by plugging a wrong power source. These are a few tips from my end. If you have any questions, again, I know you guys already know this, but I'll be available at the hardware station. If not me, we'll have more volunteers right over there. Well, that's about it for the short demo. One more thing, just let's go back to the GitHub repository. I'll tell you where it is. It's at NeurAlbertaTech. Under that, you go to 2023 Python boiler. I repeat, go to 2023. Do not go to 2021 or 2022. Yes, that would be it for today's workshop. I wanted to keep it short for you guys, so that's about it. Thank you for paying attention.